Hello, if you can just type your name and let me know who you are so I know who's in the live stream. Good morning. I am so sorry I couldn't be there today. I am in a terrible way. All right, you guys are taking a while to come in, so I'm going to go ahead and record the live stream. And whoever comes in, you can ask any questions as you see fit. If not, this will be posted later on for you to view at your leisure. So I'm not 100% sure where we were, so I'm going to start from the beginning. The difference between an independent and a dependent variable. An independent variable is a variable that you yourself change, and a dependent variable is a variable that is measured. Um, Describe an experiment that tests whether all metals are magnetic and identify the independent and dependent variable in your experiment. So, plan your experiment so you can get a variety of metals and you can test um, whether each individual metal is magnetic. The independent variable is the types of metals that you've acquired, and the dependent variable is uh, the independent variable is whether or not the individual metals are magnetic. Water has a density of 1 gram per cubic centimeter. Describe an investigation that could test whether the material has a density less than, greater to, or equal to water, and identify the independent and dependent variable in your investigation. Also identify your hypothesis. So you could do a number of things. Probably the easiest experiment is to maybe get like a bowl of water and to get several objects and test to see if they sink, float, or hover somewhere in the middle, which would tell you if they have a density less than, equal to, or greater than water. If they float, their density is less. If they sink, their density is greater. If they kind of hover in the middle somewhere, their density is equal to. Distinguish the types of investigative methods used in science. Specifically, describe the difference between a scientific experiment and a systematic observation. So, a scientific experiment is one where a series of steps are developed to test a hypothesis. So, you have a question, you develop a hypothesis, you test the hypothesis, you collect your data, analyze it, form your conclusion, and you communicate your results. A systematic observation, however, is if you were to take that information, take uh, an idea that you want to observe, something in nature. For example, one of the things that are fairly close to home are the mating practices of bull sharks. Why? Because a lot of students I know like to swim in the river. Well, bull sharks have a tendency of spawning in the river. It probably would be a good idea to know when they're spawning in the river because they tend to be very protective of their pups. So place tags on them, identify when they enter the river, how long they're in the river, when they leave, and when their pups leave. When carrying out a scientific experiment, the outcome are more valid than the results of multiple trials are consistent. If another scientist carries out the same investigation and gets the same outcome, the results of the experiment are even more valid. In your own words, distinguish between repetition and replication. Repetition is when you conduct your own experiment repeatedly. Replication, on the other hand, is when another person repeats your own experiment. Oh my God, Knox, you're killing me. Okay. All right. Okay, you can stay there. All right, so for number 6, hi, welcome. Okay. For number 6, I actually posted the information in announcements. I posted the data table in announcements, and you can actually find, I think it's page C141, you can actually find the information in there. In activity 41, if you read the individual experiments, you can actually see the individual, you can see the information on what the results mean. Just so you know, turbidity, it actually means the, hello, welcome. Turbidity actually means the condition of the water in terms of cloudy or clear. The more turbid the water is, the cloudier it is. So you can actually get that information there to compile it. Number 7, create a diagram that represents the motion of particles in a solid, a liquid, and a gas. You could do that a number of ways. A lot of students chose to use the dots method, where a solid had a dot that was tightly knit together, a liquid that was dots that were a little bit further apart, and a gas where the dots were everywhere. You could actually draw a solid, draw a liquid, and then draw a bunch of dots that are flowing all over the place for a gas. It is up to you. Hello, welcome. You want to put your name in the box so I know you came in. Identify where in the chart is a solid, a liquid, and a gas is represented. The first one at the bottom obviously is a solid. After it goes through the melting phase, it becomes a liquid, and then once it goes through the vaporization or boiling, it becomes a gas. Water has a density of 1 gram per cubic centimeter or 1 gram per milliliter. Describe what would happen to objects at various densities. So what would happen to an object at 2.5 grams per milliliter when placed in water, and explain why it would happen? Well, an object at 2.5 grams per milliliter would sink because it has a density of greater than 1. And an object of 0.5 grams per milliliter would float because it has a density of less than 1. For number 10, identify which physical properties are measured in the graph below. Boiling point, melting point, phase change, time, and temperature. Okay, time and temperature you can see on the 2 parts of the graph. Boiling point and melting point you can see are the actual phase changes, and phase change is what is occurring in the graph. And like I said, this will actually be on after this recording is completely done. This will be on later for you to be able to go back and get anything you missed. Create a diagram which demonstrates the physical property of solubility. Temperature, surface area, the less kinetic energy, the less energy of the particles makes an object solid. As you increase the temperature of the particles, there will be a phase change from a liquid to a gas. Okay, so basically you can create a diagram that shows, you can create a solubility curve. Okay, you can show something dissolving in water, let's say. So you can show, let's say, two different color particles mixed together. Examine the factors listed below. Cross out any that do not affect solubility. The items that do not affect solubility are surface area of the solute, crushing the solute, and shaking and stirring. Those do not affect the solubility, they affect the rate of solubility. Create a Venn diagram for the physical and chemical properties of matter. So what I'm going to do is I'm going to go through each physical and chemical property of matter, and I'm just going to tell you if it's physical or chemical. Substance not changed is physical. New substance formed is chemical. Density is physical. Boiling point is physical. Reactivity is chemical. Mass is physical. Thermal conductivity is physical. Electrical conductivity is physical. Flammability is chemical. Magnetism is physical. Solubility is physical. Malleability is physical. Oxidation is chemical. Describes matter is both. Freezing point is physical. Melting point is physical. Color is physical. Volume is physical. Which properties on your Venn diagram are characteristic properties? Density, boiling point, reactivity, conductivity, flammability, magnetism, solubility, melting point, and freezing point. Hello, welcome in. Oh, they left. Okay. What information is needed to calculate the density of an object? Mass and volume. Calculate the density of an object that has a mass of 8 grams and a volume of 4 cubic centimeters. The density is 2 grams per cubic centimeter. Calculate the density of an object, B, that has a mass of 16 grams and a volume of 8 cubic centimeters. Density is 2 grams per cubic centimeter. Explain whether it is possible that object A and object B are made of the same material. Yes, it is possible because they are the same density. Explain how to find the combining ratio in the chemical formula between the following pairs of elements using the periodic table, rubidium and sulfur. The combining ratio would be 2 to 1. Okay, it would be RUBS because rubidium is in group 1, sulfur is in group 6. So it would be a 2 to 1 ratio. You would use, RBS. You would use frogs to do that. Sodium and oxygen. Sodium is in group 1. Oxygen is in group 6. It would be the same thing. It would be Na2O, excuse me. Write the chemical formula for the following model of the compound, H2O. Which element is more reactive? Hydrogen is more reactive than oxygen due to less valence electrons. Okay. Draw a Venn diagram and identify the differences and similarities between an element and a compound. Elements are made of only one type of atom. Elements cannot be broken down. Compounds are made up of 2 or more types of atoms. Compounds can be broken down by chemical means. Both are considered pure substances. What are the common properties of the following element groups? Halogens are more readily combined with the alkali metals. 7 valence electrons, they can gain 1 electron. Noble gases do not form compounds, they are non-reactive. They have a full valence shell. Alkali earth metals, 2 valence electrons. They want to lose 2 electrons. They are reactive. Alkali metals are most reactive. They have 1 valence electron and they want to lose that electron. Complete a combining ratio of lithium and oxygen. You would use frogs for this method. It is Li2O. Explain the reasoning for placing hydrogen in group 1 in the periodic table instead of group 17. Because it has 1 valence electron and it gives up that electron in a chemical reaction. In other words, it forms positive ions. It moves to the negative electrode, and it forms, it bonds in a 1-to-1 ratio with chlorine. Identify the information contained in a square of the periodic table. All right, so the number 8 is the atomic number. The letter O is the element symbol. Oxygen is the element name. 15.999 is the atomic mass. How do you determine the number of protons? By the atomic number. Neutrons is rounded atomic mass minus atomic number. Electrons is by the atomic number. What does the atomic mass represent in terms of subatomic particles? The numbers of protons and the number of neutrons. So you guys don't have this in color, but the empty large circle inside is a neutron. The one with the plus sign is a proton. The one with the arrow, that is the nucleus, and the small circles on the outside with the little negative sign, those are electrons. And the electrons and energy levels are 2, 8, 18. 2, 8, 18, and 32. Oh, kill me, boo-boo. All right, so for number 23, use a pH scale above to separate the substances into the correct category. Within the category, list the substances from the least acidic or basic to the most acidic or basic. So you're going from least acidic or basic. So least acidic or basic means the most neutral, or neutral is 7. So if you look, I was just told that you guys are having trouble seeing. This will be posted afterwards. And I'm going to let Miss Peacock know that right now so she can make an announcement on the overhead. I will have it posted right after I finish the live so they can view it on their own. Can you let them know? Okay, so if you look at distilled water is the only neutral thing there. It is 7. From milk or distilled water, from milk down, milk is the least acidic, all the way down to battery acid, which is the most acidic. So you would post it in that order. From blood to household lye, that is the least basic to the most basic. So that's how you would list it on your sheet. Number 24, complete the Venn diagram using the following words or statements. Pure substances, compounds are chemically bonded, or I'm sorry, components are chemically bonded. Compounds, both are matter. Mixtures, solutions can be separated by physical means. Components retain I'm sorry, it's cut off on my list. Components are not chemically bonded. Each component retains its own chemical properties. Uh, I think that's it. A mixture of table salt and water can be used to help heal cuts. Identify the solute and solvent. The solute is salt, solvent is water, and the solution is salt water. How does the total mass of the reactants and compounds to the total mass? How does the total mass of the reactants compare to the total mass of the products in a chemical reaction? The total mass of the reactant should equal the mass of the products in a closed system due to the law of conservation of mass, because you should have the same number of atoms. Use what you know about the law of conservation of mass. How would you respond if a company said it had developed a way to make hazardous material wastes disappear? This cannot occur. This cannot occur as it is not created or destroyed due to the law of conservation of mass. Balance the chemical equation. Na plus Cl2 yields NaCl. And explain how the balanced equation models the law of conservation of mass. 2Na plus Cl2 yields 2NaCl. The number of atoms in each element on the reactant side equal to the product side due to the law of conservation of mass. Physical property, a characteristic of matter that can be observed and measured without changing the chemical identity of the substance. Examples: color, smell, freezing point, boiling point, magnetism, opacity, and density. I'm sorry, that was 29. Define the terms physical property and chemical property. Chemical property, a characteristic or behavior of a substance that may be observed when it undergoes a chemical reaction. Examples: flammability, reactivity, toxicity, heat of combustion. Define the terms physical and chemical change. List examples of each. A physical change is a change which occurs, which the form of matter is altered, but one substance is not transformed into another. Melting, boiling, mixing, dissolving in waters, shape, size. Chemical change, a process where one or more substances are changed into one or more new and different substances. Example: combustion, rusting, and mixing acids, bases, cooking. All right. Chemical reaction. A reaction change in which one or more substances, the reactants, are converted to one or more different substances or products. Signs of the chemical reaction include change in color, formation, precipitate, formation of gas, odor, change in temperature. What is the result of a chemical reaction? The creation of one or more new substances, products with properties that are different than the original substances, reactants. Describe the methods used to increase the rate of a chemical reaction. Increase in the temperature, increase in surface area, increase in concentration, increase of a catalyst, or addition of a catalyst. You guys actually saw the addition of a catalyst earlier when I broke apart water into hydrogen and oxygen, and I added sodium carbonate to the water so that you were able to see the water breaking apart faster. And number 34, there's the last question. Describe the difference between the two graphs below. The first graph is an exothermic graph. You have a little bit of input energy, and it gives you a great deal of output energy. And then the second graph is an endothermic, where you have a great deal of input energy, but you have very little output energy. So more energy was taken into the system, very little put out of the system. So I hope that helps. Feel free to message me with any questions you have. Hopefully I will be back very soon. I was not expecting to be out, but life happens. So good luck. And I will talk to you guys soon.